Please, if you not subscribe to my YouTube channel, click the link on the description, subscribe to my channel, like my page, and also share my videos. Today, I would like to just do a rundown revision for our Waec 2021 examination in physics. And today, what we want to treat is fundamental quantities and measurements. Of course, we know what fundamental quantities is. Fundamental quantities are units. Okay, I'm going to start there. Measurement in physics is something that is very, very paramount. We can't do anything as physics is concerned without giving the exact measurement of what we are doing. So the essence of measurement in physics is that it gives us a precise and accurate value for whatever thing that we are doing. So for this topic, we'll be treating fundamental quantities of unit. Of course, you know what fundamental quantities is. These are quantities that can stand on their own, and they are quantities which other quantities are being derived from. So we say examples of fundamental quantities are: number one, we have time, we have length, we have mass, we have temperature, etc. Fundamental quantities can stand and they are used as the basics for all other quantities. So units, why fundamental units are the standard international units, that is the SI units for the fundamental quantities. The SI unit for length is mass, denoted by M. The SI unit of length is in meters, denoted by M. The SI unit of mass is in kg, and the SI unit of temperature is degree Kelvin. And the SI unit for time is seconds. So, like I said, fundamental units are the length, the mass, temperature, and time. And the M here stands for the unit. The unit of length is in mass, kg, degree Kelvin, and seconds. So let's go to derived quantities. Derived quantities are those quantities that cannot stand on their own, and they are being derived from the fundamental quantities. Examples of such are: we have area, we have volume, we have density, we have force, etc. Okay, as you can see, the fundamental units are listed here: length, time, mass, electric current, and temperature. So let's know the difference between a fundamental quantity and a derived quantity. I can also say derived quantity is area, volume, density, and force. Of course, you know, whatever thing that has two combinations, it is a derived quantity. For example, area is equal to length times width. Length is measured in meters multiplied by units in meters, giving us our value to be in meters squared. This is a derived quantity. Force is the product of mass times acceleration due to gravity. The mass is a fundamental unit, therefore this is a derived quantity. So we have kilogram multiplied by meter per second square, giving our unit to be kilogram meter per second square. That is the unit for force. Okay, so we are through with that. Let's move to measurements. Okay, like I was saying, that we can't do anything in physics without giving respect to measurement. So we are going to list some of the measuring instruments that we have in physics and how we use them. But before that, I want us to treat what we call dimensional analysis. In dimensional analysis is just giving us the relationship between the fundamental unit and the derived unit. So let's take for example, wherever we see anything called mass, it is represented by m. And wherever we see anything like length, breadth, and width, it is represented by L. And wherever we see time, it is represented by T. So they might give you questions that you should calculate or find the dimensional analysis of velocity, for example. So let's do that. Velocity is equal to rate of change of displacement over time. Like we say, whenever you see distance, displacement, length, breadth, width, we are talking about L. So displacement will be replaced with L over time T. So our dimension analysis for velocity is length over T, which is the same thing as LT minus 1. Are we clear? Okay, let's try another example. When we are given power, we know that power is equal to force times distance over time. Okay? We have force multiplied by, our force is the product of what? Mass times acceleration due to gravity multiplied by s all over t. The m, our mass, is in anywhere we see mass, we say anywhere we see mass, we're representing with big M. So we are having m. Okay? But gravity now, acceleration due to gravity is the rate of change of velocity over what? Time. Acceleration is the rate of change of velocity over time. And we know that velocity, we have gotten our dimensional analysis of velocity as length over time. So for acceleration now, we'll have L over T over T. Therefore, we are having L over T multiplied by 1 over T, which is L over T squared, which is equal to LT raised to the power minus 2. This is the dimensional analysis for our acceleration. So we are going to substitute it into this value for our power, and we are going to get that the power is equal to F times X over T. Therefore, we are having F. We say that F, which is product of mass times gravity, we have M. We have now M times LT minus 2 multiplied by, whenever we see distance, we are representing it with L. So L over time. So we now have MLT minus T times L over T, which is equal to L times L give us L squared. Then this T will go up. We'll have T raised to the power minus 2 minus 1. We'll now have ML squared T minus 3. This is the dimension analysis for power. So whenever they give you any stuff to look for the dimension analysis, what you need to do first is to break it down. Breaking it down is to break it to the lowest term in terms of the constituents that makes the parameters that makes up that what you are asked to find the dimensional analysis. So like this, we analyze power to be force times distance over time, and we also broke down force as mass times gravity multiplied by distance over time. So whatever question that you are given, make sure you break it down to obtain the dimension analysis for that. And that comes to the end of everything that you are going to know under fundamental and derived quantities and also dimensional analysis. So stay tuned. In my next video, we are going to measurement. Thank you and God bless.